And talk about the design of rate limiter. Rate limiter controls how many requests client can make within a specific time frame. It acts like a traffic controller for your API, allowing, for example, 100 requests per minute from a user, then rejected access requests within an HTTP 429. This means too many request response. Rate limiters prevent abuse, protect your servers from being overwhelmed by bursts of traffic, and ensure fair usage across all the users. So we start from the requirements. So the requirements has two. One is the function requirements. Identify users by the ID, IP, or API key. And the second is limit requires based on the configurable rules. And third one is return proper error headers and status code. And the non-functional requirements. Low latency check is smaller than 10 milliseconds. And the second is like a CAP. So P is necessary and available is much important than consistency, and scale to the 1 millionth RPS. Okay, so this is the requirement. So second step is the con entities. Based on the requires, we need the request and clients, like IP, some user identify the users and the rules, right? How many requires seconds, and then we can, based on the things, we can call the API, which is called is requires allow the user based on some rules to do something. So it will call that way, right? Call this API, it will check, oh, it's okay, I will let you call the service or something. Okay, so this is the API part. Now I'm going to talk about the high level design. Okay, so for the high level designs, we have to satisfy the functional requirement. The first thing is identify users by the ID. So we can, based on the clients, we can write something here, right? So this is client, and sending the request. Based on the headers, we can choose the gateway, and we choose the gateway and set the rate limiter in the gateway here. Now we have to start from, right, sending the requests based on the rate way. This request will include the authorization and some way to identify the users first in the gateway, and it will check whether it's okay, whether it's not. If not, right, it will return, oh, I don't allow you to do anything. So it's kind of like a gate controller to identify something based on the headers information. So use the gateway to solve the first function requirement. And then we come into the second requirement is limit requires based on the configure rules. Yeah, so which means rate limiter is kind of like more insights to check the rate limiter. How could we design it? So based on the rules, we kind of like use the different algorithm to implement the rate limiter. So the first way is which is called the fixed window counter. You can see here, right? So current here, how many requests you can get in, so we can set the bound rate for here. If current now, so much, right? So we just reject this one. And second is called like slide window log, because sometimes this is nothing, but current here is too much, right? So some space will be waste. So we can improve that to use the slide window log. So limit is 8 requires per rolling minutes. So make sure current now we can handle the 8 requires, right? This way it's kind of like extend the windows to avoid the waste of some space. So sometimes implement with a heap. And then for this one, we also can, to improve the slide window, is this way more efficiency, which is called slide window counter, right? Previous 8 requires, current minutes 6 requires. We are 80% through the minutes. So based on this one, so 30% of the 8 equal to the 8.4 estimates require this minutes. So 84 is smaller than 10 is pass. So it's kind of like estimate something, and based on the history rate, it's look like the dynamic algorithm, right? So based on the previous history, and then to count current now, and also we have some condition here. So this is the slide window counter, and the fourth algorithm also which is called token bucket. So tokens refined at a read speeds, right? So for here inside, and if the bucket side is got the limit, got the size, then we remove 1 ticket each requires. If no token in the bucket, then we reject. So this is called like a token bucket algorithm. So we can satisfy the second limit requires based on the configure rules. So now we have to handle the third one, is called return proper arrows, headers, and stated codes. So for when the client is sending the requires to the gateway, right? So we can, if the too much requires over the limit, it will return the HTTP 429. That is kind of like too much requires, it means. Yeah, we can send something for the requires, and yeah, this you can see much like X rate limits, remaining numbers of requires in the current window. We're sending some informations, right? So X rate limit reset, when the rate limit reset as a unique time step is like this. So retry it after 60 seconds or 60 minutes later. So based on this one, we're sending some information back to the client, and the client will understand, oh, current some errors, too many requires, I need to stop. So this is the way to return the proper arrows, headers, and the status code. This is the way to do this. So from here and the gateway, and based on the different algorithms, you can choose different, choose one of them. And if success, it will call the write microservice to do the controller, to do the logic. Yeah, this is a high level design. Now we come in for the deep dives, which is to solve the non-function requirements. The first one is called the low latency check. So for the latency, which means we need to improve the performance. So it's a good way to do that is to use the Redis, right? So get the data is much faster than we get some specific database. So it's a good way to do that. And also second way is called like available is larger than the consistency. So for this way, it's kind of like we need to, if this one Redis is shut down, what do we need to do? We need to have some like plan B, right? So use another Redis replica that is copy the information from this Redis. So if this one shut down, we can use the Redis replication information to keep keep to make sure the system works fine. So this is the ability larger than consistent is duplicate. It's a replication way to solve this problem. And also the third one is called scale to 1 millionth requires per second. So to improve these ones, we can call it radius alliance, right? So we can duplicate radius by a lot of this. So for here we can 1 millionth, right? At least 20 radius to do this, and then which will be faster and make sure that everything works fine here. And also the gateway also can separate into the small part, then work together. So this is the way to scale to 1 millionth requires per second. Yeah, suppose we just we can handle like 50k one radius, right? So we need at least 20. So based on the radius, how many you can handle it, so divided that, then we got the numbers of the radius. So this is the scale to the 1 millionth, this one, yeah. Okay, so another thing is for the gateway, there must have some rules. So we also can use the Zoom Keeper to maintain some rules, kind of like configurations. If you update here, it will automatically update a lot of the configuration in the gateway. You don't need to change it by one. So this is the Zoom Keepers here. Yeah. So this is the deep dives about this problem. Yeah, thank you.